Okay guys, so this will be our first lecture. We're going to look at core exam number 1, Guide to Computing Infrastructure. Essentially this particular portion will be all about the motherboard and the various components that go onto a motherboard. So let's go ahead and get started. Okay, all about motherboards. This is chapter 2 of your textbook. You might want to follow along. The textbook will go into a lot more detail than I will. Objectives for this lesson include describing and contrasting various types and features of motherboards, configuring a motherboard using the BIOS UEFI firmware. This will also include updating that firmware, maintaining a motherboard by updating drivers and firmware using jumpers to clear the BIOS and replace the CMOS battery, and then finally to select, install, and replace a motherboard in a laptop or a desktop. Two different or various types of motherboards. It is the most complicated computer component. It's also the largest. It's also the one that everything else connects to. One of the first things to consider if you're building your own computer, you want a motherboard that is adjustable or adaptable, one that can expand with your system. Things to consider: you want the form factor, how big you want a mini desktop, you want a full desktop, you want a laptop. That is form factor, the size of the motherboard. What type of processor you want, AMD or do you want Intel? What type socket? Various different processors take different sockets in different chipset manufacturers. Most of your chipsets are going to be Intel. If you're building your own PC, you're probably going to use an Intel chipset. Expansion slots. This is particularly important if you are building a gaming PC or a development PC. You want to have suitable expansion slots. You can install various and sundry cards. And also, what are the kind of connectors? Nowadays, a lot of your connectors are just going to be USB, but for the most part, if you're building, like I said a while ago, a development PC, a gaming PC, a video editing PC, you're going to want some other you're going to want some other connections that won't normally be available in just a standard motherboard. Okay. Let's go ahead and look at some of the parts. This is an Asus Prime Z370P gaming motherboard. It's an ATX form factor, which is not the largest, but it's the next largest. An LG8 1151 8th generation socket. This is not the most modern motherboard in the world, but it's not the oldest either. So first of all, let's look at the parts. The first thing, and the probably most important thing, is the socket. This is where the processor chip is installed. Then the various pieces of the chipset. This is an Intel chipset. You're going to end up with both your northern and southern buses and the BIOS chip, all the different other chips that are not the processor that are permanently installed in the motherboard. This round circle here is the battery. This is the battery that keeps your BIOS alive. It keeps your BIOS clock alive when your PC is turned off. These different slots here, these are PCIe slots. This is a PCIe by 16. These are PCIe by 4. So you've got basically 1, 2, 3, 4, 5 slots for expansion of this motherboard. The different interfaces for like USB and for network, the built-in network card, all those interfaces are here on the back side of the motherboard. This is where your RAM would go. You've got 3 slots for DDR4 memory, and that's basically the basic parts of your motherboard. These 4 slots here are for your SATA, S-A-T-A. That's where you hook your hard drives up, and essentially that is all the important parts of the motherboard. Motherboard form factor determines the size and features and also makes it compatible with power supply. So if you get an ATX, you're going to need an ATX power supply, etc., because they have matching power plug-ins for the different sockets on the board. Micro ATX is smaller than Mini ATX. Mini ATX is smaller than ATX. Mini ATX is also called ITX. The following slides show different examples and compare the sizes. So this is a mini ATX form factor. It has a processor cooler and modules for memory installed. So there's your processor cooler. That's the fan that cools off the chip. And there is the RAM. Those are the memory modules. Power supply will plug in here. This is the heat sink for probably the north bridge. You have two PCIe slots here. These are PCIe by 4. And then this is probably a PCIe by 16. So you only have 3 expansion slots here. And this is a regular PCI slot. So this would be an older board because you don't see a lot of just regular PCI slots anymore. That's not a common thing. These would be your SATA interfaces. You got North Bridge and South Bridge. We'll determine how to tell which is which shortly. All right, next we have a mini ITX. This is a much smaller processor. You can see it doesn't have a fan, it just has a really large heat sink. You have one PCIe by 4 slot here. You have your SATA slots, or your SATA connectors here. Your power supply will plug into here. Your monitor, VGA monitor, will plug into here. This is a serial port, so this is really an older board because that's a 9-pin serial. That is a, you won't see these much anymore, but this is a modem and a mouse port. Nowadays most of your mouse and modem will plug into USB, which are these and these, but that is what modems and mouses used to plug into, and you can tell by the purple and the lime green color. Like I said, these are USB, all these are USB. These are your sound, your audio imports. That's mic, the red one. The green one is audio speakers, and the blue one is headphones. And then that would be your onboard network connector there. So these would be the various and sundry parts and pieces that make up the motherboard for a mini ITX motherboard. So ATX is full size. This is what you would use for maybe a gaming or a development PC. It's a large board. It's got a lot of adaptability. It's got a lot of PCIe slots. Usually it's got a lot of different things that you can connect to. It also has a lot of room, so you can install maybe a liquid cooled system, things like that. Micro ATX is smaller. This would be for like a business PC. And then a mini ITX, that's a very small form factor used in really cheap PCs, and also your home theater systems that don't require a whole lot of resources. Basically, you just got a video out and a place to plug in the processor. So that would be the 3 different form factors. Also, you need to be aware of the sizes: 12 inches by 9.6 inches or 305 millimeters for 244. These will be test questions. I don't know why, but they choose to do that. The micro ATX is perfectly square, 9.6 by 9.6, as is the mini ITX. So both of those are perfectly square. The ATX is not. It's rectangular shaped. And this is a kind of a comparison. That would be a mini ITX, that would be a micro ATX, and then a regular ATX. Notice these two are square. This one is not. Intel and AMD chipsets and processor socket. So definition of a chipset, you need to be familiar with that, and also a socket. It's a rectangular interface with pins or pads. Some of them have pins that you plug into the socket. Some of them have pads that just correspond to pads on the back of the chip. 2 major chipset manufacturers and processor manufacturers, Intel and AMD. You should be familiar with both those. Intel chipsets, these are fairly modern, but maybe not the most modern. Coffee Lake, Kaby Lake, Skylake, Broadwell, and Haswell. Those are different names of chipsets. Since the release of the second gen core processors, like Core i5, Core i7, Core i3, and so on, you can know which generation of processors it fits in by the 4 digits of the model number. For example, a Core i5 6200 is a 6th gen, and that's what that 6 stands there. And the 8th generation LGA 1151 socket with the cover, And so this would be the cover. It flips down over the socket to hold it in. It's ready to have a socket placed in there. So what you would do, you would install the socket, you would close the cover, and then you would put the heatsink glue on, or the heatsink processing paste, sorry, word I was looking for there. And then you would connect the fan or the whatever cooling system you're using. Sockets for Intel processors 1150, 1151, 1155, and then for servers and high-end workstations 2066, 2011, and 1366. So these would be sockets for workstations or servers. These would be just regular desktop sockets and also laptop sockets. 7th and 6th gen of an 1151 open socket and bottom Intel processor. So there are the pads. These are little metal contacts, and these are the corresponding pads. You'll notice there are gaps, and those gaps correspond to gaps in the socket. You lay that down on top, and those little contacts make connection with these contacts, and that's how your processor communicates with the motherboard. Same here in LG 1366, the socket cover removed and the load plate lifted. So that's where you're going to install the processor. It also has pads. Zero insertion force, ZIF sockets. That means you do not push, press, or in any way mash on the chip. You just set it down on the socket, and it should slip right in. So you need to know what ZIF stands for. And there should require no pushing. If you have to push, or if it doesn't fit in to the socket perfectly, you need to pick it up and change it around, change the orientation, and put it back in again, because you've got something lined up wrong. AMD chipsets, current AMD chipsets and socket categories. TR4, that's a Threadripper socket, uses an AMD X399. AM4 chipset uses for Ryzen and Athlon. Those are very common in desktops. AM3 and 3 Plus are PGA sockets, and that's the processor they use, Piledriver Bulldozer, and then F2M is an older PGA socket for Athlon excavators and A-series chipsets. Those are probably not being manufactured anymore at this time. Match processor to a socket and motherboard. You must pay close attention to the model numbers, and you need to, absolutely, most important thing, check on the internet, check the documentation. You need to make sure that the processor you're purchasing fits the socket and the motherboard, because if not, what you're going to do is spend a lot of money that basically is wasted. To match processor and socket, look at the motherboard manufacturer's website, look at the documentation, and it will tell you what processors that motherboard supports. You can also search Intel or AMD websites for an exact processor to make sure the socket uses, because like I said, if it's not, the sockets, or pardon me, the processors tend to be expensive, and you don't want to waste a lot of money on a chip that's not going to work. Fine lines found on the top and bottom of the motherboard are traces. This is the copper trace, or the copper patterns that are printed onto the motherboards. They're circuits and paths that enable data instructions and timing and power to move from component to component. The bus system is a system of pathways used for communication, protocol, and methods. A protocol is just a set of rules and standards for communication. So the bus, you're looking at the north bus and the south bus, the north bridge and the south bridge. We'll talk about those a little bit later. On the bottom of the motherboard, you can see the bus lines terminating. So these lines here are running to the socket for the processor, and all this travel here, all this printed copper, these are the bus lines. PCI Express, these are expansion slots. Currently comes in 4 sizes, by 1, by 4, by 8, and by 16. That's what the X stands for. So PCI Express by 1, PCI Express by 4, and what determines this number is how long the socket is. The number after the X refers to the number of lanes available. So if there's only 1 lane available, it's a by 1. If there's 4, it's by 4, and so on. For example, PCI X4 contains 4 lanes. By 16 slot is used for graphics cards that require a lot of throughput. to provide extra wattage required for cards. Sometimes the card may have external connectors that, pardon me, the card may have 1, 2, or 3 connectors that allow the power supply to connect extra cables to it. So it's not just getting power through the socket, it's also getting it and plugging it into external connectors. If the card is a high-level video card, for example, that has multiple fans on it, they're going to need extra power to make that run. Okay, so these little chips, or these little sockets here, are PCIe by 1. That means they only have 1 lane available. These are by 16s. That means they have 16 lanes available. Those are something you could hook a video card into. These are regular PCI slots, and they are old. So you got 3 types of expansion slots: PCIe by 1, by 16s, and then conventional PCI. You won't see these on most modern boards anymore because PCI is just old. This is an example of what the documentation for a motherboard would look like. It outlines what slots are available. So PCI Express 3.0, that's a version of the communication protocol. PCI Express 3.0 by 16, that means there are one of those slots that uses PCI Express 3.0. It's a 16 slot, which means it has 16 lanes available. There's one PCI Express 2.0 by 16, that means it also has 16 slots available in the X4 mode, which means it's divided up into 4. We'll talk about that later. PCI Express 2.0, that's the same protocol as this one, and then 2 PCI slots. It supports AMD Quad-Fire, Crossfire, and regular Quad Crossfire and regular Crossfire. So if PCIe 1 and 3 are occupied, then PCI 4 will run at X2, because what that means is that the PCI E4 borrows some traces from the other 2 slots, and if these are being used by the cards in their own slots, then this card, this slot will only run at X2 mode instead of X4. SATA power connectors, these are what would power your hard drive. That's what most hard drives or solid state drives would use for a power supply. Now SATA is more common. Molex was used for the old IDE drives. You will not see that on any kind of modern board, except possibly if you've got a board that has an optical drive like a DVD or a Blu-ray, you might see that, but for the most part you're going to see SATA power. Conventional PCI slots and buses are slower than PCIe. That's why PCI is not used anymore. Slots are slightly taller. That's how you tell the difference. Transmits 32 data bits in parallel and operates about 500 megabits. You need to know that. Used in all types of add-on cards, but not usually anymore. Card risers used to extend the slots. You may have a card riser plugged into one slot that has multiple slots on it. So particularly if you've got a low profile case, you may not have room to install a regular card, so you can use a riser card that comes off of the motherboard, and then it has slots at a right angle to the motherboard, so they can stick out over the motherboard instead of sticking up from it. And basically these can come in all types: PCI, PCIe, etc. A PCI riser card looks like that. So you'd plug that into the motherboard and you'd plug another card into that, and that sticks out over the motherboard instead of sticking straight up from it. Onboard ports are integrated ports. This would be USB for the most part. PS2 mouse and keyboard, that's the lime green and the purple socket we saw a while ago. Video, you can have VGA, and nowadays you can have data port or data video as well as HDMI video built in. Sound is usually built in unless you have a really nice sound card. Network is almost always built in. Now you have gigabit network built into the motherboard, and then eSATA ports are external SATA, which means you can have an external SATA drive bank. IO shield, that's a plate installed in the case, provide holes in the back for input-output ports. That's where all the USB ports and network ports and things stick out the back. That's the aluminum that protects the rest of the case and keeps it from just being open in the back. And then internal connectors, you have USB internal. You can have M2, which is the small hard drives that clip into the motherboard. SATA, which is your regular drives like solid state drives, and then IDE connectors are the very old style hard drives. So once again, that's PS2 for mouse and keyboard. You got 2 USB slots here. That's a digital video interface there, HDMI there. These are USB 3.0. You can tell the difference because these are blue and these are black. And then that's a Ethernet RJ45 connector. This is sound, so the red one would be mic, the green one would be speakers, and the blue one would be headphones. All right, so essentially what we have here is an M.2 slot. The card is very small, and it comes in an angle and then folds down, and these 3 nuts, essentially you can put a screw, and based on the length of the card, that will hold the other end of the card down. And that is what a M.2 slot looks like. This is an M.2 card, and they're keyed specifically based on where the notches are. You have a 5-pin wide key on this end, a 6-pin wide key here, and then you have a combined 6 and 5-pin key on this one. And the key basically tells you how to put the key into the slot. And so that's the slot we were looking at, and it fits in an angle, and then you would press it down and put the screw in on this end. IDE, basically you'll never see one. It uses a 40-pin connector. I believe there might possibly be questions on the test for this, but in real life you'll probably never see an IDE connector. I've got one here I'll let you look at just to kind of let you know what it looks like, but unless you're working on a really, really old motherboard, you will never see an IDE. USB header is used to connect cables from a motherboard to the USB ports on the front of the computer case. So these would be an internal from the motherboard to the inside of the computer case. Then you've got external cables that plug into the front of the computer case, and those are connected to the motherboard via the header. That is an IDE connector. That's what the IDE data connection looks like. And like I said, there are 40 pins there. It's a white ribbon cable. This is the cable itself. It's a gray flat ribbon cable with a 40-pin head. You'll notice it's keyed. This one is blank. There's no hole here. And you'll notice there's no pin here either. And so that tells you which way to put the cable into the connector. USB connectors, these would be USB internal connectors. You would have a USB cable going from these connectors to the inside of the front of the case, and basically that allows you to have USB ports on the case besides sticking out the back. BIOS UEFI setup. Basically we're going to configure a motherboard. This needs to be done before you install the software, before you install the operating system. So firmware on the motherboard is used to enable and disable connectors. If you want to enable HDMI or enable VGA, if you want to enable onboard sound or have your own sound card or whatever. It also controls the frequency and other features of the CPU. If you want to overclock, particularly if you're using an AMD, you would set up your overclocking inside the BIOS. Security features, you can establish a BIOS password. You can also, and particularly if you're a Dell PC will allow you to set up intrusion detection, so that if your case is opened and you're not there, then the next time you boot up your PC, then your PC will send you a message that the case has been opened. It also controls what happens when the computer first boots, what kind of diagnostics are run, and it will also monitor and log various activities on the motherboard. Motherboards after 2012 use UEFI firmware. Prior to 2012, it just used BIOS. And Unified Extensible Firmware Interface improves BIOS, but includes BIOS for backward compatibility in older devices. Microsoft requires it in order for Windows 10 to be certified now. Of course, Windows 11 also requires it. It's also required if you have a larger hard drive or larger storage than 2 terabytes. It offers secure boot, which means a system can not boot up if it doesn't have the appropriate drivers that are digitally signed. and trusted by the motherboard and computer manufacturer. For backwards compatibility, it can boot from an MBR hard drive and provides BIOS boot through its compatibility support mode CSM, which means if you can't get booted from a USB drive, sometimes you may have to go and change this setting in the BIOS, which we'll talk about that. In fact, we have talked about that probably. If you've already set up your class PC, you're aware of what needs to be done to UEFI so that you can boot from a USB drive. Accessing the BIOS, generally you're going to hit F1, F2, or delete during the boot. Sometimes you may have to hit it multiple times, but don't hit it fast. Hit it about once every second and then wait and then hit it again. But don't click it, because if you do, you'll lock the motherboard and it will not give you the menu that you need. If it does give you the menu, then a setup screen will appear, and it's fairly self-explanatory. More of the modern UEFI BIOS setup programs will have they'll have a mouse interface, but some of the older ones just use the letter key or the arrow keys. This is what one looks like, and basically you've got the main page. This gives you an outline of what your system is set up with. Configuration, this is a configuration of your chipset and different ports. This would be your hard drive here, for example. That would be a 6 gigabyte. This would be another hard drive, also 6 gigabytes. This would be a 1.5, so that would be a third hard drive. Or no, pardon me, that would be a DVD drive. So that would be a third SATA port, and then the eSATAs aren't connected. Performance, basically this is where you would set up overclocking, things like that. Security, you set up your BIOS passwords and things here. Power, this tells how your PC reacts to clicking on the power button. The boot order, what is the first device, whether it's a USB, whether it's the motherboard, or pardon me, hard drive, what device that the PC will attempt to boot from first, and then exit. When you click on F10 or F10, basically you'll save any configuration changes you've made and exit. Otherwise, you just exit. Your configuration changes will not be saved. So make sure that if you change something, you click on F10 to save it before you exit, because if you don't, then all your work that you just did will be gone. This is a more modern UEFI BIOS utility. This would be mouse controlled, and it's a lot more friendly interface. It has a temperature, it has a fan controls here. This is for an Asus. Boot priority, UEFI, if you're going to boot from a USB, you're going to need to go there. Your CPU information, basically it's giving your temperature and voltage. Same thing with your memory, your different slots. CPU fan, this will allow you to set the power mode for your fans, whether it's running all the time or just running every now and then BIOS clock up here. Changing boot options, basically this is the boot priority. This will allow you to boot from USB or from the hard drive. When installing an OS, you will want to set it BIOS UEFI to boot from the DVD if you're using an optical drive, which not so many systems do that anymore. If you're booting from USB, you definitely will want to set that up in the BIOS so that it boots first from USB. You want to put that first in the boot priority. If you're installing from a server, so you're going to pull your if you're going to pull your operating system files from a server that's on the network, then you'll want to enable PXE boot to LAN. And then you also have options to boot to the Windows DVD. If you happen to have your Windows setup DVD handy, you can boot to that in case you need to troubleshoot. Once again, this material is a little bit dated here because not many computers anymore have DVD drives or optical drives. Basically what you're going to be booting to is a USB drive if you're going to install an operating system that way. However, because the test is a little bit behind what is current, you're still going to be familiar with DVD and how to boot from that. Secure boot allows you to set various security protocols involved in booting. It was invented to prevent malware from launching before the operating system, because sometimes, especially with rootkits, that can happen. Secure boot works only when you're in UEFI, not CSM, and the OS has to support it. Windows 10, Windows 8, and various Linux distributions support Secure Boot. It holds digital signatures, encryption keys, and drivers and databases stored in flash memory on the motherboard and the BIOS chip, as well as on the hard drive. When enabled, it checks the drivers, the operating system, the applications before UEFI launches, which means if malware has infected the PC and it tries to launch on boot, then the Secure Boot system will prevent that from happening. Security here, basically, you can set up an administrative password as well as user passwords on the BIOS, which means the user will not be able to boot unless they have access to that. You can set those here. AMD Platform Security Processor, you can enable that. That's specific to AMD chips. And you can also clear that key there. Secure Boot is enabled there. Secure Boot status, it tells you if it's enabled or not. Platform mode, if it's user platform or admin platform. Secure Boot mode, there are various and sundry settings here that you can adjust. The boot screen allows you to select UEFI mode, and that is required for Secure Boot to be enabled. Use CSM for the older BIOS devices and drivers, and older hard drives. So especially if you've got an IDE drive, you're going to need to set this up so that you can boot from the older drives. You'll have to set it for CSM, which is compatibility support mode. That means go back to the older BIOS settings. When you want to change boot options, this would be on a newer Asus BIOS utility. These are the different boot devices, and you can set which one you want it to boot from. Basically, you'll go in here and pick the one. Let me find where it says boot. This is where you'd set CSM. You'd enable that or disable that, and then this is where you'd turn Secure Boot on. Right now, this device is set to boot from an HP DVD. You would click this button and select either hard drive or UEFI or USB, and that will allow you to set which boot option is option number 1. And so after that, then it would go to the hard drive. But it would try to boot from, say, for example, USB. If you're trying to install operating system from a flash drive, you would need to set that for USB and make sure that UEFI is enabled. And then the first thing that your PC would do when you turn it on is try to boot from USB. So if you've got a USB flash drive plugged in, it will boot from there, and if it finds bootable files, then it will start an operating system from there, or it will start the setup program for an operating system. Onboard device configuration, you can enable or disable those using BIOS. For example, you can enable network ports. If you've got an external network device, or you've got a PCIe network card, and you don't want to use the onboard for some reason, let's say you've got a gigabit network card, but your onboard card's only 100 megs, then you probably would want to disable that. Same thing with USB ports, you can enable or disable them. And also if you've got a high dollar gaming video card and you want to disable your onboard video to save the resources, that's what you would do there. Overclocking means you're cranking up the processor past what is recommended by the manufacturer. This is particularly common in AMD. In fact, they make it very easy to do that inside the BIOS. It's not recommended for a business computer. You might do it for a gaming PC or home PC, but probably not something you want to do for a business PC because it really runs the risk of overheating and also damaging the processor. But if you happen to do that, this is where you would enable and disable various and sundry parts of the motherboard. For example, if you want onboard audio, that's where you would disable or enable that. Same with USB ports or audio in the front of the PC. You may have a green, red, and blue plugs in the front and the back, and you can enable that or disable it here. HDMI, if you have built-in HDMI audio, you can enable or disable that. Onboard LAN, you can disable or enable that. USB, all the different things that are built into your motherboard, you can enable those or disable those here under configuration. Other security features besides Secure Boot, you can have power on passwords, which means you turn it on and the BIOS asks for a password before it will continue to boot. LoJack, if your computer is stolen, it will broadcast its location on the internet every time it's booted up. Drive password, if you don't want people accessing the drive, you just want them to use network storage, for example, you can password protect the drive. Drive encryption, you can set up drive encryption here. All these different security features are available in the BIOS UEFI. Power on passwords, that prevents unauthorized access even to booting up. It won't even boot the operating system up if you don't have that password. So basically this is where you would set up that configuration. You'd set it up under security in the BIOS. LoJack laptops, generally this is important because they're easy to steal, and so CompuTrace technologies, those are embedded within the motherboard to protect the system against theft. Must subscribe to a service, so it doesn't, you don't just enable it, you also have to subscribe to LoJack. The service can be used to locate a laptop anytime it boots up and connects to the internet, and once located you can give commands through the internet to lock the laptop or delete all the data on it, things like that. Some motherboards allow you also to set a password in order to access the hard drive. It does not encrypt the data, but it does encrypts a few of the organizational sectors so that not all the data is available on the hard drive. Many motherboards contain a chip called a TPM, that's Trusted Platform Module chip. It's a BitLocker encryption. Windows 10, 8, 7, and also 11 work with this chip. BitLocker encryption allows you to encrypt the entire hard drive, and essentially it's unbreakable encryption, so once it's encrypted you don't have to worry about someone stealing your hard drive and getting your data off of it. It assures that the drive cannot be used in another computer. It will not work and you can't break the encryption. It can only be used with other encryption software that may be installed on the hard drive other than BitLocker. If the motherboard fails and is replaced, you're going to need a backup copy of the key to access the data on the hard drive, otherwise your data is lost. Virtualization, if you plan to use this as a virtual machine, then you're going to need to set up virtual machine. You're going to need to enable hypervisor, is the virtual controller on Windows machines. So you will need to set up some kind of a controller, enable it in the BIOS. Once you've got all your settings, you need to exit, but make sure that you save your settings. If you don't, then your settings will be discarded and you'll be back to where you were. So these are your options. You can save and reset, you can discard and exit, you can go back to the original defaults. Those are the different options that you have once you start to exit the BIOS setup utility. Motherboards causing problems, you want to use a new operating system or hardware device. You might need to update the motherboard drivers, and basically and also you may need to update the BIOS. So device drivers, if you're not familiar with that, you need to know they are programs that allow hardware to run on a PC or on a computer. A DVD or CD that comes with the motherboard contains a user guide and drivers for its most common components. After installing the motherboard, you can install the drivers and later update them by downloading updates from the website. Or, if you happen to be on Windows, it'll probably send you updates. Make sure to get the correct drivers for the operating system that you have, whether it's 64-bit, whether it's 32-bit, Windows 11, Windows 10, Windows 8, whatever you're using. For example, if you're using an Asus computer, then this would be the type of motherboard, the brand or model number of your motherboard, and then the drivers that you could download and update would be found here. So that would be specifically for an Asus computer. You download drivers, utilities, things of that nature, also documentation from the website, and then you'll be able to update your hardware, your devices, by running a BIOS update or running an install program. Process for upgrading and refreshing a BIOS is called flashing the BIOS or flashing BIOS UEFI. The reasons you might want to do that, If the system hangs at odd times, some motherboard functions have stopped working. You get errors when trying to install new hardware or software, or you want to incorporate some new features. Occasionally they send out new features in a BIOS flash. To flash it, always follow the directions. Motherboards can use one of these methods. You download an update from within a BIOS setup program. You use a USB and boot from there, or you run an express BIOS UFA update. Cautions to be aware of: do not, whatever you do, turn off the power or interrupt the process, because if you do, there's a very good chance you'll brick your motherboard and you can throw it away, because at that point you cannot repair it. Once you've damaged the BIOS chip and once you've destroyed it, or you've replaced the the BIOS information with information that won't boot, then you can throw that motherboard away and start over. Don't update the firmware without good reason. Unless there's a good reason to, the risk does not outweigh the reward. Make sure that you back up all your data in case you do happen to brick the process while you're working there, if the power goes off, and then make sure you get the correct update file and don't interrupt the process. Using jumpers, there is a small plastic connection, and it's generally on two small metal posts or pins that stick up off the motherboard, and usually it will have open jumper. That means that there's no cover, and a closed jumper has a cover on the two pins. Jumpers can be used to basically clear the BIOS and set it back to default. If you've forgotten a password, or some disgruntled employee has set up a password in the BIOS that they didn't tell you what it was before they left, then you can use this jumper to restore the BIOS to default. Also, if you fail when you're flashing this, a lot of times the jumper will restore or get rid of the update that you tried to do that didn't work. And so basically that's what it looks like. It's open 6 pins, and you'll be able to find it. The jumper is basically just a connector, and when it's sticking off to the side like that, that means it's parked on one pin just to keep up with the jumper, but it's not connected at the moment. The PC will not run when that jumper is connected, by the way. So what you would do is you would connect it. Now it's running, it's connecting these 2 pins, and when that happens, that restores the default settings to the BIOS. So you would plug that into those 2, you take it off and put it back on one like this. You just have to leave it on there for just a little bit, for just a few seconds, and then put it back like this. And at that point, then your BIOS has been set back to factory default. So here's a better explanation of it. Normal. This is a different mode. This one does not stick off to the side. It actually has 2 pins that are for normal booting, and then if you want to shut down the BIOS, or if you want to shut down the BIOS, you pull it off, and then you can reset it to different settings based on where you put the jumper position. CMOS, that is the small round battery that keeps your your BIOS alive when your computer's turned off. CMOS has a small amount of memory on it, and that keeps information like the time. A CMOS battery keeps your BIOS clock working, because if your BIOS clock is not right, a lot of times your operating system will not boot. So to replace the CMOS battery, choose the exact match, the exact same size. It needs to be an original from the manufacturer, or one that is compatible to the manufacturer. Power down the system, unplug it, press the power button to drain the power, and then remove the case. Make sure you have a static strap on, remove the old battery using a flathead screwdriver, push the new battery into place, reconnect everything, and boot back up. Motherboard is considered to be field replaceable. You need to know how to do it, and you need to know what type of motherboard, and also like I said, you need to know how to do it, but it is a technician serviceable part. How to select it: basically, your best bet is to pick exactly the same model that you have, unless you're consciously doing an upgrade, because a lot of times the parts that you have will not fit on the new motherboard if it's a more advanced motherboard. So select the board that best suits the needs of the computer's current configuration, unless you're consciously upgrading and you already have all the upgrade parts. If you're upgrading to a processor, upgrading RAM, upgrading to different PCI slots, then make sure that you have those components that you need. Otherwise, your computer's motherboard, the new motherboard, may not work with what you have currently on your computer. So select a board that best suits the needs of the current configuration, or that has moderate room for expansion. These are the questions you want to ask yourself, or you want to ask someone else when replacing the motherboard. How is the motherboard to be used? Is it going to be business PC? Is it going to be a development PC? What are you building with it? What form factor? Is it ATX? Is it ITX? Because you cannot cram a large motherboard into a small case. What brand of processor? Intel and AMD are not compatible with each other. So if you have an Intel processor, you're going to have an Intel board. Same with AMD. And then finally, what processor type of memory? What speed and type of memory? Is it DDR4? Is it DDR3? What type of RAM are you going to be using? Also, embedded expansion slots, internal and external connectors. Do you have those things available? Are you currently using them, and are they the same on the new board? Does the board fit the case? Does the input-output shield in the back fit up with all the ports? Are you going to need to get a new input-output shield? What about the price and the warranty? Nowadays, manufacturer, if it's Asus, if it's Dell, if it's HP, whatever, the manufacturer doesn't so much matter. What matters is the warranty. You don't necessarily want to use equipment from somewhere like Bob's Computer Land, because they may or may not offer the kind of warranty that a major manufacturer like Dell or Asus would offer. Check the reviews. It's not a bad idea to check the reviews online. How extensive and user-friendly is the documentation? Particularly if you're looking at a foreign-made board, like a Chinese-made board, English may not be their first language, and so the documentation may not be as helpful as it could be. So once you verify the right board is selected, get familiar with the documentation, remove the components. So unplug the processor, unplug the RAM, unplug any cards, things like that. Install a new I/O shield if necessary. If the board has a different I/O placement on the back, then you're going to install a new shield. Install the board using the right standoffs. Install all the pieces, the processor, the cooler, the RAM, cables, the hard drive, the video card, things like that, and then plug the computer into a power source, attach a monitor, keyboard, and mouse, and you should be back up and running. Boot the system and enter the BIOS setup. Observe the post. Power on self-test is what POST stands for, by the way, and verify there are no errors. Make sure that Windows starts with no errors. Install any motherboard drivers that it says are missing. It will give you messages that say you need to install chipset drivers and things like that. If not, you can also look at the hardware device manager, and that will tell you if there are drivers that need to be updated. If you have other expansion cards, network cards, video cards, audio cards, you can install those. Verify that everything's working. Make sure that this would be a good time to do any updates that you want to do as far as operating system goes, and then verify. You want to set up passwords in the BIOS if that's a thing that you choose to do. Once you've gotten all that done, then your computer should be completely and fully upgraded. When we're placing the motherboard in a laptop, you're going to have to completely disassemble the entire thing. A lot of times laptops are inexpensive enough that replacing a motherboard is a lot of trouble compared to just buying a new one. Once you've gotten it done, you want to update Windows and device drivers, make sure Windows is working properly, disconnect the AC adapter and press function plus S plus V to set the battery in ship mode. Remove the hard drive and slot compartment cover and the hard drive. Remove the slot compartment cover that gives access to the memory or mini PCIe cards, and then remove those components. Remove the keyboard bezel. There are a lot of screws, and this is specific. There may or may not be 13 screws. There may be more. Detaching the touchpad, you may or may not need to do that. Once you've gotten everything disconnected, though, then you'll replace the motherboard and reverse the process to reassemble the system. This is just a picture basically showing you how to replace that. Remember, there are a lot of screws. If you lift up on the motherboard and it doesn't come out freely, you need to start looking for screws that you haven't taken loose yet, because it's really easy to break that motherboard at the screw holes. And once you do that, then basically there's a good chance you've damaged your system. Motherboard is very complicated. This is the summary of the things you need to know. This is the things that you'll need to know for the chapter test. Motherboard is the most complicated of the components inside the computer. Most popular form factors are ATX, micro ATX, and mini ITX. The chipset embedded in the motherboard determines the kind of processor, either Intel or AMD. When matching a motherboard to a processor, use only the processor that motherboard is specific to. Once again, Intel motherboards and chips and AMD motherboards and chips are not interchangeable. Components built in the motherboard are called onboard components. Those are the things that, like onboard data, onboard video, onboard audio, onboard network cards. Those are things built into the motherboard. They don't have a separate PCI card. A 40-pin IDE connector is really old, and you probably will not see one. The firmware that controls the current motherboard is BIOS if it's an older board, or UEFI BIOS if it's a newer one. UEFI supports GPT partitioning, which means you can use drives bigger than a terabyte. Booting using UEFI requires secure boot in Windows. Motherboard settings, go into the BIOS UEFI and you can edit the settings. You can enable things like passwords and security, or you can enable or disable different pieces of hardware. Secure boot uses databases to confirm that, and it will not boot up if the drivers are not signed, and then you can update the motherboard according to the manufacturer's instructions. And then finally, when flashing, don't update without a good reason, and make sure that you don't interrupt the process. You can clear the process, you can clear the BIOS settings using the jumper. Make sure that when you do install a motherboard, that it's fit for the case and for the chip and for everything else that you're going to plug into that motherboard. Finally, usually with laptops, it's more cost effective to just throw away the old laptop and buy a new one. Okay, so that is the first lecture for this class. That pretty much takes you through a motherboard. You'll want to go through this video. Also, you want to look at the different reading assignments, and you want to maybe go through the slides yourself. But for the most part, that will give you the information that you need for the first chapter exam. So make sure you get that done. Remember, you have the option to retake the chapter exams if you need to. So if you didn't do well on it the first time, go back and redo it. Until the exam expires, you can retake it as many times as you want, and I will keep the highest grade. If you have any questions, I can be reached through the Canvas inbox. That's the best way, or via email, whiter@grayson.edu. Either one of those two ways is effective. And I will see you in class. Have a good week.